Hello, thank you for watching this video. So on this video I'll be doing question 5 of November 2022 question paper, mathematics paper 1. So I have these straight line functions drawn here. So I'm going to read the statement, then proceed to answer the questions that follow. Okay, so let's go. Question 5. The graphs of g of x and its inverse are shown in the diagram below. So the graph of g and its inverse, they are here. So you are told D and B are x and y intercepts of g. So D and B are x and y intercept of g. C is the x-intercept of the inverse of g. And the third point is that the graphs of g and its inverse intersect at A. Let me read this again. The graphs of g and its inverse are shown on the diagram below. And you are told that the following: D and B are x and y intercepts of g, respectively. C is the x-intercept of the inverse of g. The graphs of g and its inverse intersect at A. So what you are told, you are given g and its inverse. Here is g, here is its inverse. And then you are told that D and B are the x and y intercept of g, respectively. And C is the x-intercept of the inverse function. So you're told that both g and its inverse intersect here at A. That's what they're telling you here. So, question 5.1. Okay. Write down the y-coordinate of B. So they want you to write the y-coordinate of B. This here, okay. This here, this line, this is the y-axis. Y-axis, also known as line y is equal to x is equal to 0. And this one is the x-axis, also known as y is equal to 0, because along this vertical line here, x is equal to 0, and along this horizontal line here, y is equal to 0. So they want you to write the y-coordinate of B. So y-coordinate, B lies on this line here, on g of x, is equal to 2x plus 6, right? So you want the y-coordinate of that. You know the x-coordinate of that because it lies on this line here. So you know that there, x is equal to 0 in that point B, because it lies on this line, x is equal to 0. Then to find the corresponding y value, you substitute your x value on your equation, then you find the corresponding y value, which will be your y-coordinate of the intercept, which is your y-coordinate of B. So to do that, you say, okay, g at 0 is equal to 2 times 0 plus 6. So the y-coordinate is equal to 6. So g at 0 is equal to 6. So the y-coordinate of B is equal to 6. So every time when you are asked to find the y-coordinate and you know the x-coordinate, you simply substitute the x-coordinate on your equation. Then you find the corresponding y-equation, the y-coordinate. 5.2. Determine the equation of the inverse of g in this form of x is equal to mx plus n. So you are given the equation of g, right? So they want you to find the equation of its inverse. You know, to find an inverse, you reflect about this line here. About this line y is equal to x. So you just reflect this equation along the line y is equal to x. So what happens is when you reflect along or about y is equal to x, your x and y become y and x. So your x and y coordinates swap around. So now, on the original equation g, you have g of x is equal to 2x plus 6, right? So it will become what? X and y are going to swap around, which means now your x will be here on the inverse and your g of x will be here. That means it will become, because you just swap x and y around, which is in the place of x you put your y, in the place of y you put your x. So which means here you will have x is equal to 2 g of x plus 6. And then from this equation here, you solve for your g of x. So transpose the 6 to this side, x minus 6 is equal to 2 g of x, divide by 2, divide by 2. So g, your new g of x is equal to x 1 over 2x minus 3. So this is your inverse, this one. So this is your g inverse. That's how you find the inverse. You just have to know that you reflect along this line. If you reflect along this line, your x and y become y and x. Put your x here and the y there. Solve for y, which is this. You find that your inverse is this. This is how you do it. So go to 5.3. Determine the coordinates of A. They want you to find the coordinates of A there. So here, your equations, your inverse function and your g function, they meet there, which means they have exactly the same coordinates. Their y coordinates are the same and their x coordinates are the same. So you know that A have x and y, right? So which is your A is equal to have your x and g of x here, right? Which is also equal to A, x and y of the inverse. This is what that means. So your x, your A there have coordinates x and y here, your A. Have the coordinate x and y. So you can find the exact coordinates by substituting your x coordinate on the original equation and find the corresponding y value, which will also be the same thing as the inverse, because the inverse also passes through that point A. So what you say, you can be like, okay, if the coordinates of our function g are the same as the coordinates of our inverse, which means what this means, you have A, x and g of x. This is the same as your A for your x and your inverse function at x. So this guy is exactly equal to that, and this is equal to that. But this won't help us much, but at least we can do something with these guys, because if your two coordinates are the same, are equal, which means the x value is equal to x value and the y value is equal to y value. So you can just equate this one and that guy. So your g of x is equal to 2x plus 6, which is your inverse, which is equal to inverse function 1 over 2x minus 3. Transpose the 6 to this side and transpose this guy to this side. So you have 2x minus 1 over 2x is equal to minus 3 minus 6. So you punch this on a calculator. This is 3 over 2. X is equal to minus 9. Then divide by 3 over 2. Divide by 3 over 2. So this goes away. X is equal to what? Punch this on your calculator. you'll find that it's equal to -6. So your x coordinate is equal to -6. Then to find your corresponding y value, like we did on the first question, if you have the x value and you want to find the corresponding y value, you substitute your x value on the equation, on your function equation. So now you have that g of x is equal to 2x plus 6. So g at -6 is equal to 2 minus 6 plus 6, which is your g at -6 is equal to, pass through the calculator, this is -6. Therefore, your coordinates for A, I need more space. I can write them here. Your coordinates for A, your x coordinate is -6 and your y coordinate is -6. This is what you have. So you have the coordinates here for A to -6 and -6. B, we said is 0 and 6. This is what you have. I hope this is clear. Let me clear the board and then we'll go to the next question. 5.4 reads as follows. Calculate the length of AB. They want you to find the length of AB, this length here. So use the distance formula. Your A is -6 and 6, and your B is 0 and 6. So the distance from A to B is equal to this: x1 minus x2 all squared plus y1 minus y2 all squared. So you can say this is your x1, y1, x2, y2. x1 minus x2, which is -6 minus 0 all squared, plus y1 minus y2, which is 6 minus minus 6. Oh, sorry, this is -6 here. So you have 6 minus -6 all squared. So distance AB is equal to this. So you punch this straight on your calculator. Square root of -6 minus 0 all squared plus 6 minus -6 all squared. This is 6 root 5, this one. 6 root 5. This is the distance here between the 2 points. Distance AB is equal to 6 root 5. So we'll go to the next question, 5.5. Okay. Calculate the area of triangle ABC. So let me clean this. 5.5. They are saying calculate the area of ABC, of triangle ABC. So they want you to calculate the area of triangle ABC, which is this triangle here. This triangle here. They want you to calculate the area of that. So let me draw this triangle. Let me try to draw something similar to this triangle. Something like this, then like this, then like that, right? A, B, C. So you have the length here to be 6 root 5. Okay. So when I deal with such things, I always use this area rule. The area rule is saying, okay, area of triangle ABC is equal to half. So this side here is your small b, this side is your small c, and this side here is your a, right? So what this is saying that your area, if let's say in this case I have this angle here to be theta, right? So if I want the area of this triangle here, it's going to be half the product of this side and that side, the sides that include this angle, which is it will be b times c sine of the angle that I have, which is sine A, which means it will be 1 over 2 times b. Only multiply the sides that include this angle. So it's going to be b times c sine theta. So what I have to do is to find all the sides of this triangle of mine. In this case, this always work. Find the triangle of all the sides in one angle. That's what you need to do. Just find what you need to do is to find what the sides, the length of all this triangle in one angle. Once you do that, you can use this formula, which means if you find the angle here, this angle here, you'll just have this side and this side, sine of the angle here. So if you find the angle here, it will be half of this side times this side, sine of the angle that is there. That's the area rule, right? So we need to find the length b, which is the distance AC. So the distance AC is equal to x1 minus x2 all squared plus y1 minus y2 all squared. So your A, you said it's minus 6 and minus 6. Your B is, your C is, we didn't find the coordinates for C. They didn't ask us. But you know that the y coordinate here is 0 because it's on the line y is equal to 0. This is the line y is equal to 0. So if you know that the y is equal to 0 here, and this point lies on the inverse, the equation of the inverse is g inverse of x is equal to 1 over 2 x minus 3. Right? That is the what? Yeah, that's the equation of our inverse. So we know that the y value there is 0. We know this part is 0. So 0 here is equal to 1 over 2 x minus 3. So we solve for x. We want to find the corresponding x value. We know y is 0 here. So for c, we want to find this value here. Then transpose your half the side. So you have negative half is equal to minus 3. Then divide by a negative half, divide by negative half. You will quickly discover that your x is equal to 6 here. So you have 6 and 0 here. Those are your coordinates. So you want to find the distance between A and C. So the distance AC is equal to square root of what? Let's say this is your x1, y1, it's your A. What is your C? Your coordinates for C is 6 and 0. Let's say this is x2, y2. So we say x1 minus x2. What is our x1? x1 is minus 6 minus x2. Our x2 is 6 all squared plus y1, which is minus 6, minus y2, which is 0 all squared. Then you can punch this in your calculator as well. Square root of -6 all squared plus -6 0 all squared. This is 6 root 5. So this side is also 6 root 5. Right? So this side is also 6 root 5. So what do we do now? We say, okay, we can find this distance of this side. So we want to find all sides here in one angle. Once we find all sides in one angle, once we find all sides, we use the cosine rule to find the angle, one of the angles. But I'll find A in this case. After finding A, we can use our area rule formula. So let's find the distance BC. x1 minus x2 all squared plus y1 minus y2 all squared. So B, the coordinates of B is 0 and 6. The coordinates of C is 6 and 0. So the distance BC is equal to x1, y1. x2, y2 is going to be 0 minus 6 all squared plus y1 6 minus 0 all squared. Punch this in your calculator. 0 minus 6 all squared plus 6 minus 0 all squared. So our distance is square root 6. Oh, it's 6 root 2. That's our distance BC. So we have our A to be 6 root 2. So we completed this triangle now. We have all the distances. Now what we want now that we have all the sides, we want to find this angle here. So let's find the angle here. I'm going to delete all the calculations that I made for distance so that we can have space. So I'm going to use the cosine rule. You know it from grade 11. That it says, what angle do we want? We want this angle here, right? So it's going to say, okay, what do we have? A squared, which is that side squared, is equal to B squared, which is this side, plus C squared, which is that side, minus 2BC cos angle A, the angle that we want. So we have A to be equal to 6 root 2 all squared, which is equal to B squared, which is 6 root 5, plus C squared, which is also 6 root 5, minus 2 B, which is 6 root 5, 6 root 5 cos A, right? So punch this in a calculator. 6 root 2 all squared this is equal to 72 is equal to this. What is that? 6 root 5 all squared. This is 180 plus another 180 minus 2 times 180, which is, this is 360 cos A. So you want to find that angle there. So you have 72 is equal to 360 minus 360 cos A. Transpose this to that side. So it's going to be 72 minus 360. So this is equal to 72 minus 360. It's equal to minus 360 cos A. So that is minus 288 is equal to minus 360 cos A divided by minus 360 divided by minus 360. So this gone, cos A is equal to this divided by minus 360. This is 4 over 5. Then angle A is equal to arc cos, which means shift cos of 4 over 5. Therefore, your angle A is equal to shift cos 4 over 5. This is 36.87 degrees. So this angle here is 36.87 degrees. Therefore, we go to our area now. So the area is equal to 1 over 2 B times C sine A. So it's going to be B C sine A. So therefore, A is equal to 1 over 2 times B. What is your B? Is 6 root 5 times 6 root 5 sine the angle, this one, which is 36.87. Therefore, your A is equal to, punch this in the calculator, 1 over 2 times 6 root 5 times 6 root 5 sine our angle. This is 454 square units. So this is your area. And I think you're done with this question. Hope it was very clear, and I hope I'm not flying